looking at vector functions and space curves. And we're looking at this basically because it's going to prepare you for what's going to happen after this section. So you learn about what a vector function is. You will learn actually how to differentiate and integrate vector functions. Nothing new to you. If you know how to already differentiate and integrate, you will be able to do this. Okay, so this is not a difficult section at all. Basically, it's just needed. There are just some definitions in here that you will need to know, especially when you see it's appearing. These definitions or these terms will be appearing later. Okay, so what is a vector function? It's a function ROT. It's a vector, so it's in bold, of the form as follows. And so I gave you an example there. The domain is R and the range is just a set of position vectors. F of t, G of t, H of t are the components of the vector function. And then if these functions are continuous, then R of t traces a path as t varies. And this path consists of these points, x equals f of t, y equals g of t, z equals h of t, called the parametric equations. And the set of all of these points is called the path or space curve C. So these here are called the parametric equations of C. We're going to sketch some of these space curves. This first one will do it by hand, and the others I'll show you how to do it on your calculator. All right? So we're going to do it by hand, so we're going to do it in 2D. So let's sketch the curve with vector equation R of t equals sine t, t. Okay? So x is sine t and y is t. These are the parametric equations. I didn't give you the values of t. We're looking at a trig function, so I'll take t between minus 2 pi and 2 pi. So we're going to draw a table, and then we will draw the graph, okay? Okay, let me draw the table. I'll do the table here, and then I'll do the graph on the other side. So I'm going to put t here, x and y. And remember, x is sine t, y is t. And then let's go from minus 2 pi to pi. It's the same thing. You remember how you drew parametric, how you sketched the curve corresponding to parametric equations? You should have done that in Calc 2. It's the same thing we're doing here. So 0 pi. I think I want to put in let's see that. Let me put in a negative pi over 2 just in case. We don't have to, but I just want to see what's going to happen, okay? And then that would enable me to know basically what the curve is going to look like. So let me put pi over 2, pi, 2 pi. You could insert a 3 pi over 2, but I'm not going to. Okay, so when you put that, x equals sine of t, so this is 0, 0, negative pi over 2 minus 1, 0, 1, 0, 0. And then y is t, so it's the same thing. Minus 2 pi, minus pi over 2, 0, pi over 2, pi, 2 pi. And enjoy your axes. X and Y. So x goes from minus 1 to 1, and then y goes from minus 2 pi. Okay, so let me put a minus 2 pi here, minus pi, 0, pi, 2 pi. x from -1 to 0, -1, 0, 1. So put in these. And then all you do, you just plot points. So you have 0 minus 2 pi, that's here. 0 minus pi, that's here. Okay, that's the reason I put a minus pi over 2. I wanted to know what was happening. So you have -1 minus pi over 2. So that's here. 0, 0. 1 pi over 2 here. 0 pi. 0, 2 pi. So you see what's happening here? Should give you an indication of what the curve is going to look like. So you just complete it. Something like that. And make sure you put the arrow in the right direction. Okay? So that's the curve. And you can have, you know, application like a particle moves along that path. Okay? So you will know the kind of path it is taken. Any questions on this? So that I will not ask you to draw by hand, because you can draw these on your calculators. So that is what we are going to do now. So if you get out your calculator, and I will get mine up on the computer, okay? I will show you one 2D, and then you can practice the 3Ds on your own. I'll do maybe 1 or 2 3Ds. So open a new document. We're going to start with a 2D graph. As a matter of fact, let's do the one we just did, the sine t, okay? So I'm going to rely on you to look at your notes so that you can see the instructions, okay? Because I have the calculator there. So open a new document, and then I want you to add graphs. So in your menu, add graphs, okay? And then you'll see the Cartesian system there. And then menu, and then graph entry edit. And then we want to draw a parametric curve. So you click on that. Now this is what I am getting on mine. So this x1 of t will be the first, the x equation, the y1 will be the y equation. Now this would be your t values. Let's leave it at that. 6.28 is 2 pi. If you wanted to put it at -2 pi, you can, but let's just leave it so. And okay, that's okay. So enter here sine t into the x1 t. So that's sine, and then t down here. And then into the y. What happened here now? No, why isn't this? Into the y, right? Enter t. And as I said, leave this as is, and then just press enter. And then what you should see is half of the curve that we just drew. Okay? Okay. So now let's do the 3D now. So go back to menu. No, we need a new document. I'm sorry. Let me escape of that. How do I do that again? Okay, here we go. No, I don't want to do that. I want that. Okay, new document again. I want you to add graphs. Now we go into 3D. This is 2D, right? So go back into menu. And we're going to be doing a lot of that. So try to pay attention to that. Go into view for 3D. And go into 3D graphing. So we have 3D graphs. You're going to do something like that later on, but not yet. We want to do the parametric. So go back into menu. Go back into 3D graph entry edit. And go into parametric. And then you will see the 3 functions. Okay, look at your notes. Tell me what is the first space curve I have there. What's the first function? Is it 1 plus t? And 2 plus 5t? And minus 1 plus 6t? Okay, so enter that for me, please. So you go 1 plus t. The other one, now be very careful when you're entering 5t. Do not enter it as 5t. When you actually have to put the multiplication in between. So you go 5 times t. You have to do that for multiplication or else you will get an error. And then what's the next one? Minus 1 plus 6t. Now before you 6 times t, don't plot it yet. What do you think you're going to get? The type of functions you have there. What do you think is going to appear? A line. So let's just see, enter and see what you get.
See a line in there?
Yeah, look at it. It's quite small actually. Look at it right here. You see it? Okay, try the, what's the other one? Let's just try one more. What do you have?
Cosine t, sine t.
Cosine t, sine t, and t. So if you want, you can save that document. I don't want to save it. So open a new document and do the same thing. So we want cosine t, you said, right? Oh, what am I doing? What am I doing? Where's my I thought this was backspace. Where's backspace? Oh, where is? I'm not seeing. Where is it? Where is it?
Middle right side, far right. 4th button down, right?
Where it is? Yeah, that might work there. Aye. Okay, let's do it again. I cleared everything. I need to take out my calculator. Everything there is just too small. Okay. Yeah. Okay. So that's how you do them. So if you want more practice, as you notice, I gave you quite a few there. So you can just practice on your own. We wouldn't do all of that. Any questions? Okay, let's minimize that. And let's continue. Let's do some calculations now. So we're going to do some derivatives and integrals. Good practice now because you're going to start doing differentiation very soon. Okay? Derivatives of vector functions. The derivative R prime of a vector function R is defined by, now that should look really familiar to you, the limit definition, but we're not going to use that. I just wanted to define it. R prime of t is the tangent vector to a curve defined by R. And the unit tangent vector is denoted by t of t, and you might see that appearing later on, that particular notation. which is r prime of t over its length. So let's do an example. Find the unit tangent vector t of t at the point with the given value of the parameter t. So you have r of t and at t equals 0. So we have a number of steps. What we first need to find is r prime of t. So let's do that. And I chose this example especially because you have to use the product rule. So I wanted to start introducing that to you or reminding you of that because it's coming, okay? So let's start. R prime of t is equal to, so we put in our angle brackets. We differentiate in t e to the minus t. So remember what it is. Differentiate t, which is 1 times e to the minus t. So you have e to the minus t plus t times the derivative of e to the minus t, which is minus e to the minus t. So let's change this minus to that plus to a minus. Let's take this out. So that's the first one. 2 arctan of t. The derivative of arctan of t is 1 over 1 plus t squared. So that's 2 over 1 plus t squared. Differentiate 2e to the t, you get the same thing. Okay. Now this happens when t is 0, so you want to find r prime of 0. So put t equals 0 in here. The first function here is 1 because this is 0. The next one is 2. The next one is 2. So that's r prime of 0. Now find the length of that. That's the next step. The length of that, which is the square root of 1 plus 4 plus 4, which works out to be 3. And so we want, well, t of the unit tangent vector, so we'll put t of at 0, okay? Because we're looking at it at 0. So basically you are just dividing r prime of 0 times it's divided by its length, which is the vector 1 over 3, 2 over 3, 2 over 3. That is the unit tangent vector. Okay, that's just practicing differentiation. That's what it is. Okay, I think the next one is yours. So try it. Try to remember the derivatives of these. Now, I mean, I didn't put it in angle brackets. So you have the I, J, and K. There's no problem. You just differentiate, okay? If you want angle brackets, then by all means. And we'll go over it together. Okay, let's go over it. R prime of t. What is the derivative of cosine? Minus sine t. I. What is the derivative of 3t? 3. What is the derivative of 2 sine 2t? 4 cosine 2t. Yeah, we have to use the chain rule here, right? It's cosine 2t, and you need to multiply by 2. Now let's find r prime of 0. What did you get here? What vector is it? I'm going to use angle brackets. It's easier. 0, 3, 4. What is the length of r prime of 0? 5. Beautiful. So that's the square root of 0 plus 9 plus 16, which is 5. And so your final answer, t of 0, is 0, 3/5, 4/5. Fantastic. Okay? So that's derivatives. Okay. Now let's do some integrals. So again, there's a definition for these integrals defined in terms of Riemann sums. That sounds familiar? Beautiful, isn't it? but we're not going to do it. We're just going to integrate. So if you have the vector function r of t and you want to find the integral of it from a to b, you integrate each term, each function, each component function from a to b. Okay, so again, this is nothing new. Let's do some evaluations. Oops, there's not much space here. Okay, evaluate this. Alright, so let's put our square brackets. What is the integral of 2t? One person. T squared. Another person, what is the integral of 4t? Nice. Another person, what is the integral of minus cosine t? Minus sine t. Beautiful. And that goes from 0 to 1. So the first vector you get is when you substitute 1, and you'll get 1, 2, and I'll just put this as minus sine of 1 and leave it like that. Minus, now put the 0, and you get zeros all the way. And so the final answer is 1, 2, minus sine of 1. Integration is all coming back to you now, as well as differentiation. Hint, hint. So at least start going over your differentiation, because that's the next thing we're going to be doing, okay? Go over all your differentiation rules. The quotient rule, the product rule, the chain rule, you know. Is it your turn? No, it's my turn, right? There's another one down there, right? Okay, so let's do that one together. One person, what's the integral of u cubed? U to the 4th over 4i. What's the integral of u to the 5th? U to the 6th over 6. What's the integral of u to the 7th? Not, you can't get it to the same 7th. U to the 8th over 8th. From minus 2 to 2. And by the way, this is going to be 0. Can anybody tell me why I was just able to put 0? Anybody remembers that rule?
Positive is equal to area negative.
Yes, yeah, but just by looking at the function itself is even, you see? And because you go from minus 2 to 2, it's going to be 0. I didn't know how to calculate. But we don't put just 0. Sorry, that's a vector, isn't it? So we need to put our 3 zeros. Try number 3 on your own and we'll go over it together. Okay. Let's integrate. What's the integral of the first component? One person. Good. Next component, somebody else? And one more, somebody? Very good. Wait, why do I put J? We want K. And we're going from 0 to 2. And upon substitution, what did you get? What's the answer? 32. Beautiful. Okay. Questions on this integration? And basically, I just listed an application of this. If you have a velocity function given by a path and you want to find the displacement vector, then you just integrate it. Okay, so the displacement vector from r of a to r of b, that is the vector starting at the point on the curve corresponding to t of equals a and ending with the point corresponding to t equals b, can be determined by integrating the velocity function r prime. Okay, so that's just an application I just listed before we go on to the next topic. So let's find the length of a space curve. Go back to Calc 2 when you're finding the length of an arc or the length of a curve. So that formula should look really familiar to you. Okay? So it's similar to the formula you learned for arc length. So suppose that a curve has vector equation as follows, and t is defined between a and b. And of course, f prime, g prime, and h prime must be continuous. Then the length of the path r of t is the integral from a to b of the length of r prime of t, or which is equal to the integral from a to b of the square root of the sum of the squares of the derivatives. And if r of t is the position function of a particle moving in a line, then the length of r of t is the total distance traveled by the particle. Why do I have article? It should be particle. Put a little p in there. Okay. Let's do an example. Let's do more integration. Let's find the length of the curve. So what we should do, let's write down x, y, and z. So x is 2t, y is t squared, z is 1/3 t cubed. Let's derive all of them. So dx dt is 2, dy dt is 2t, dz dt is t squared. Let's square all of them. Dx dt all squared is 4. Dy dt all squared is 4t squared. Dz dt all squared is t to the 4th. So from the formula, the length of the curve is the integral. We have t between 0 and 1, so we're going from 0 to 1. And then we are integrating the square root of the sum of all of these things. 4 plus 4t squared plus t to the 4th. Now that's where problems begin, because sometimes you may not have no idea how to integrate that. So check to see if you can find the square root of that. Now the way this is written, I know that 4 plus 4t squared plus t to the 4th is a perfect square. You can factor that. What is that? Anybody can see what it is? It's what squared? T squared plus 2. Beautiful. And so this is the integral from 0 to 1. Oh, I forgot my dt here. Of t squared plus 2 dt, which is equal to t cubed over 3 plus 2t from 0 to 1, which works out to be 7/3. That is the length of the path. Okay. You try that one on your own. We'll do it again together. Okay, let's do it. So x equals t, y is 3 cosine t, z is 3 sine t. Can I have the derivatives? Dx dt, dy dt or y prime, negative 3 sine, yeah. And z prime or z dt, 3 cosine t. Now let's square them. X prime squared is obviously 1. y prime squared is 9 sine squared t, and z prime squared is 9 cosine squared t. So what do we need to do? Integrate from -5 to 5 of square root of 1 plus 9 sine squared t plus 9 cosine squared t dt. Now I hope you did not plug this into your calculator. I know that you did. So you can simplify that. This is trigonometry. What do you notice? Tell me, Michael.
If you factor out the 9 sine squared t plus cosine squared t equals 1.
Beautiful. I need you to see these things. Are you annoyed with yourselves? So this sine squared plus cosine squared is 1, isn't it? Doesn't that look a lot nicer? So this is just the square root of 10. Isn't that beautiful? Who knew? Right? Yes?
We know.
Because I asked who knew, and you said we know. Okay. Yeah. You know now, right? You have to recognize these things, and I'm telling you, these things are going to come up. So start going over these trig identities. They're very important. Okay, so your final answer after this is going to be, that's just a constant. So I'll just put square root 10 times 5 minus 5, which is 10 square root 10. Okay? And I suspect if you had plugged that into your calculator, that integral from -5 to 5, you may not have obtained that answer, I suspect. Might have given you a real weird answer. Okay? Any questions?
So good.
Motion in space, velocity and acceleration. So let us examine the motion of a particle traveling along a path, r of t. The velocity function denoted by v of t is just a derivative, r prime, right? The velocity vector points in the direction of motion. So remember, it's a vector. Velocity is a vector, right? If you want to find the speed, the particle's speed, then you'll have to take the magnitude or the length of that velocity vector. And of course, acceleration is also a vector and is defined by r double prime of t, or v prime of t. So let's do some questions here. Find the velocity, acceleration, and speed of a particle with the given position function, get r of t, and you have at t equals 1. So let's do it. Velocity first. So velocity is v of t, which is equal to r prime of t, which is 3t squared minus 1 8t. And so v of 1 is 3 minus 1 8. Okay, so that's just derivatives again. Acceleration. So acceleration a of t is just v prime of t. So differentiate the velocity function, 6t 0 8, and a of 1 is 6 0 8. And then finally, the speed is just the length of v of 1, which is the square root of 9 plus 1 plus 64, which is square root 74. Okay? So that's that question. I think the next one is yours, isn't it?
No.
It's not yours? I'm doing another one? Why? You can do that yourself. Isn't that the last one?
Yep.
Oh, so why are you letting me do it? You do it. Because I did not put do, you think that I have to do it? No, you do it. That was an error. Okay, let's do it. Can somebody give me v of t, please? 1, 2, t, 0. And so v of 1 is 1, 2, 0. Acceleration a of t is 0, 2, 0. And so a of 1 is the same thing, substitution there. And then finally the speed is square root of 1 plus 4 plus 0, which is square root 5. So easy, and you wanted me to do it, right? Okay, that's it.